Yellow will be the 12 volt. Put that on the ground over here. And we have 0.9 volts. It appears that we might need to source a new power supply. People in the know will have an idea what it is that I'm going to do, and I suspect that you're not going to want to watch this. I would like to try and address the damage in two parts. The first part will be the cosmetic damage on the outside of the bezel, and then we'll work on reattaching the post so that we can attach the bezel to the frame. The crack at the top starts on this edge, rolls down to about right here. That's where the break in the plastic is, and then we have a stress crack that goes to about right there. At the bottom, we have a very similar one that starts at the edge right up here, rolls down to about here where the plastic is actually broken, and then we have a stress fracture here. The cosmetic damage where you can actually see the break in the plastic, we're not going to be able to address that, but we can address the flex. So at the bottom, as you can see, it comes out like that. And on the inside, I think you can see that where we have our crack that goes to about there. At the top, we have a very similar break like this. And we could leave those as is. However, I am a bit of an extremist and would like to try something that you see online all the time. And that's where you take a piece of metal and embed it into the plastic. That metal will reinforce the gap or the break. And as you're fusing it to the plastic using a little bit of heat, it really will kind of weld itself in place. That would give us the strength so that our cracks are lined up the way that they should be. And then we can take a little bit of fiberglass and put it on the inside to finish everything off. Now the Industrious Me has tested this offline, and I have an example here where we have a piece of ABS plastic, and right here is that staple that I've embedded. And all I really did was put a couple of bends in the staple and used my soldering iron to push it into the plastic. It didn't come through to the other side, and it appears to be quite solid. When we're done, we have something that looks a little bit like this. I'll go ahead and clip the staples off, and we're going to have to sand back a little bit of the ABS that came up. Added a bit on top just to solidify the joint. And from the other side, we still have the crack. However, it's not protruding, and it's actually quite solid. So funny story, I spent several hours trying to get these posts to line up in the bezel, and by the time that I finally got them to sit up straight the way that they were supposed to, I forgot to turn on the camera before I glued them down. The intention was to get them to line up and then take some fiberglass resin and then basically dab both sides to glue them in place. However, I thought, well, let's try that acetone thing. So for that, I basically just kind of dabbed a little straw into my acetone and put 2 little drops on either side. It softened up the plastic like it was supposed to, and I let it sit for about an hour to cure, basically for the acetone to evaporate, and we have a super solid connection. You can't even tell it's broken. Now that we have the bezel all fixed up, we can put the case back together, but before I do that, I would like to pull this power supply out and give it a quick test. When we inspected this power supply in the last video, I noted that it was a 250 watt and that the sticker on the side had released. Obviously we can just kind of glue that down, but I noticed something. On the top we have a missing screw. Strangely enough, when I dumped the case out of the box, a screw had fallen out. I wasn't sure exactly if it was on the bench before or if it came from the case. I set it aside and it looks like we found out where it goes. Of course, that is a little suspect, so let's pull the top off of the power supply and just kind of take a look inside. Normally inside power supplies they are pretty dirty, sometimes because of use and sometimes because of the manufacturing process and the fact that you are not supposed to open these up. However, as we look closer, there appears to be considerable amounts of corrosion, or what looks like corrosion. But we'll go ahead and fire it up and see what happens. Short of plugging this power supply into a motherboard, I do not have a way of testing the individual lines on the AT power connector. But I can use an old power supply tester. It has a 20-pin connection on one end, 4-pin Molex, 4-pin CPU, and 4-pin floppy. We can just plug in our Molex, turn the power on, and check the voltages. Moment of truth. Power strip on. Rocker switch on. We have 5-volt power being lit up. Nothing 12 volt. And the fan in the power supply is not spinning. Alright, so the plot thickens. Let's go ahead and put a load on the power supply. Now we saw that the 12 volt light did not activate, and it should have off of a Molex connector. Maybe that was a loading issue, so let's go ahead and put a hard drive on here and see if any of that changes. Power strip on. Activate the rocker. And nothing. Let's go ahead and take our voltmeter here and we'll just probe the Molex, see what happened. This should be the 5 volt. 6.94 unloaded, so that makes sense. Yellow will be the 12 volt. Put that on the ground over here. And we have 0.9 volts. So it would seem that in addition to the physical damage on the chassis, one reason that he couldn't sell it possibly was that the power supply was dead. People in the know will have an idea what it is that I'm about to do, and I suspect some of you will not want to watch this. One of the reasons that these AT chassis are so popular is because of the digit display. Now these numbers here don't actually correspond to anything in the PC aside from what you set them to be. For instance, by default this one was set to 150, but then if you enable the turbo, it goes down to 50. Now since this will be a Pentium Pro system, I'm going to reach back into a bit of the history, and my very first Pentium Pro was a 180. That was overclocked to 200 megahertz. This only has a 1, so what we're going to do is split the difference. I'll make this a 180, and since the Pentium Pro motherboard does not use a turbo, this will be the default display all the time. To configure what the display says, we need to set them with these jumpers. Now these jumpers correlate to one leg on the 7-segment display. By moving one over, you're going to be turning one leg off and turning another on. To help you figure out which ones are which, and especially with a case that comes with the manual, you get a sheet that looks a little bit like this. That square is highlighted is the one that is default, we have a 5, which is 5 there and 5 there. This grid corresponds to the turbo and the non-turbo modes, and then our 0 is in the corner. Now by adding 2 jumpers, I was able to change the digit display. We have a jumper that's sideways here, and another jumper that's sideways there. That corresponded to changing to 180, and if we change the turbo, we have 50, which is really what I wanted. Well, and there we have it. System is back together. We have a brand new power supply. We fixed the bezel. We got our digital display hooked up. If you have any questions, please leave them in the comment section down below. As always, thanks for watching, thanks for subscribing, and I'll see you in the next one.